Hi, this is Roel Schipper. Thank you for watching. I want to show you a short instruction of how to use MapleTA in testing engineering material. And let me show you an assignment that we used in the past week for an exam in our Master Building Engineering among the first year students of the Master. This was an exam about acoustics and or about building physics in general, and one of the questions was about acoustics. Here you can see the situation that we gave the students. You see schematically a building and a source of a sound source of a building site, in this case a drill which produces a lot of noise, and each of the students is provided with a set of noise level data which is parameterized among the students, so each student works with a different set of numbers. What is parameterized? The frequencies, the sound level on each frequency, and also the distance between the sound source and the facade of the building. Well, you can see how the answer is formulated. This is a logarithmical answer, as you see quite often in acoustics. And it consists of two parts. The first part is what is the level of the sound 1 meter from the drill, and the second question is what is the level of the noise on the facade of the building, which is a bit further away from the drill. And apart from this, there's also a weighing of the sound in decibels in a particular way, which corresponds to this type of noise. Okay, let's have a look at how we translated this into MapleTA. If you're not familiar with MapleTA, it's a testing system which is built upon Maple, and we use it quite often for all kinds of engineering questions. So let's go to this particular question about acoustics. It is this question here, and you can see it here. Maybe I should go to the original question, 1 second. You can see the question here, and also some other questions from the same exam. The nice thing is that it's all presented very neatly in a digital environment, in a nice layout with colored images. You could even use videos in it, and it has all kinds of possibilities for question types, presenting graphs, so you can take students through quite a large variety of questions and using different type of questions in the same exam. Okay, let's go to the exam. If I click on it, you can see it in more or less the same way as it's presented to the students. So you get a preview here of the question on acoustics. You can see the same image that we saw earlier, but now you can see that the numbers are already generated for this particular student. And if I refresh it, you can see that it will also change. For example, this 90 decibel. If I refresh the assignment, then you can see it has modified. I refresh it once more. You can see that accidentally is the same. But these numbers are varying by algorithm, and each student is provided with a different set of starting values. Here the students can fill out the answer. In this case the unit is given, but you can also ask them to provide the unit. And then the nice thing is that MapleTA also recognizes the unit system that we normally use from SI, so it will distinguish millimeters from meters, or similar conversions that we see quite often in engineering. Okay, so let's have a look at what happens if I fill out a number. So let's assume that this is 80 decibel, and a bit further away it's 60 decibel. I can grade it. Well, I just have a lucky shot maybe, but I'm afraid I didn't do too well. Now, you can see here with my 80 decibel I scored no points, because the real answer should be 93. And with my second answer 60, it should have been 79. And you can see the grade for this particular question is 0. So let's have a look at how is this implemented in Maple. We now enter the question designer environment, which is a web-based editor. You can see here we have some text and images that have been uploaded to the system. Here you can see the parameterized noise levels that we discussed earlier. You can see there's a string which says that it's a variable which is defined later on in an algorithm, which I will show you later on. And here you can see the answer field, and if I click on it you can also see that this is indeed a variable which is calculated by an algorithm, and the student is allowed to give an answer within a certain accuracy. You can also accept all kind of notation conventions. You could even provide feedback in case of, let's say, a wrong answer. In this case we didn't use it because it was an exam, but for training exercises it could be very helpful to provide feedback for all possible wrong answers. Well, there are other question types. If I would enter a new response area, you can see what type of questions you can use in MapleTA. Here on the left hand side you can see the list of available question types. Well, we know of course the multiple choice, a numeric answer like the one that we just showed, which can also be parameterized. That also goes for the multiple choice questions. So for each student there could be a different correct answer, also based on values that you have provided the student. You could even do things like scan documents. So students are allowed to upload a document for later grading, or making a drawing and have it graded. Of course, in an exam setting this might not be very helpful, but in training situations for coursework it can be very useful. You can have essay questions which should be graded by the lecturer based on keywords. You can even have it already marked with yellow, for example, if students use the proper terms in their answer. But all kind of other possibilities are also available. This is quite a rich combination, and in combination with the parametric options that you have, you will be able to do a lot. Okay, let's have a look at this parameterization. If I click on the algorithm window, you can see a very small script that defines for this particular two questions the variables that the students are provided with. In the first place, the noise level. You can see for each frequency it's within a given range with steps of 1 decibel. Then the answer of the first question is given here, a logarithmical answer based on terms of the 5 frequency bands, which I have defined here. I took them a little bit apart to be able to debug the code and not make too many typos. Usually what I do is put the correct answers also in the question, so that I'm able to check myself whether the algorithm generates the correct answers. And here for the second answer you can also see that's depending on the distance between the building and the source of the drill, and this is also with a simple parameterization calculated. Okay, the nice thing about MapleTA is that you can also show quite efficiently how students did individually or as a group, and it can also provide you with quite good item statistics, which says something about the quality of your questions. So have a look at that. If I go to the gradebook, I can show you, for example, the item statistics on the questions that I have prepared in this exam, which says something about which questions were okay and which were not too good. You can see the list of questions. We had 25 questions, and here we see our particular question that we just discussed on acoustics. And here you can see how the students did. Well, you should see the header of the row, but the first column is important, which is the average score on this question. And usually the discrimination value is also very helpful, the third column. We can see that the average student scored 70% on this question, and that the discrimination value of this question was 23%, which says something about the distance between the people that did well on this question and the people that did not too well on this question. The higher it is, the more discriminating the value is, and it should also discriminate between the better students and the lesser students based on the full exam. So this score says you something about whether good students indeed also did good on this particular question, and the lesser students indeed also did less on this question. If that is the case, then this question helps you to discriminate the better from the lesser students, which is what you want to do in an exam. You can also have individual results from users. I will do a search now and also hide it a little bit for privacy reasons. I don't want to show you the names of the students. Here you can see my class list with individual scores of each student, and the nice thing is I can also grade each assignment where necessary for all the students. So I can, for example, this particular question, go through it for all the students and compare how they did. If you have to do manual grading, this is very handy, because then you can go through all the assignments quickly. You don't have to refocus from question to question, but you can look at, for example, question 3, the answers from all the different students, and grade them in one go, which can help you to work quite concentrated on grading one question. Okay, let's have a look. Here you can see the matrix of how students did for every particular question, and let's have a look at how they did on this acoustics question. Here you can see once more the item statistics, and here you can see how each individual students, and the students' names are here on the left, how they did on this particular question. Well, this student scored 7 out of 7, which is 100%. The weight of the question was 7. Here you can see the values that this particular question student needs to work with, and the answers, and so on for each student. Oh, the students obviously didn't do very well. The first answer was incorrect, and the second answer he or she did not fill out. And so you can go through very detailed answers of all students for this particular question, and the same goes of course for all the other questions in the tests. Okay, this is what I wanted to show you. Hopefully it was useful. If you have any questions, please email me at my mail address at Imperial College or at TU Delft, Roel Schipper. Thank you for watching.